Hey there, Math 126 fan. Last page of the Summer 25 Math 126 Exam 2. This question was about understanding double integrals and how to work with them. The first question was about reversing the order. Now there's something, I think I know what it is, but over the years I've noticed these questions tend to make students pretty uncomfortable. So that's why in class I gave some key tips. Now, there's still people that made some mistakes, so let's talk about those key tips again. So first, it's really good to identify that these refer to X, and I called those tick marks. But the most important thing in these problems is drawing your region, and it's really about drawing what these inner bounds mean. What is the pattern? What are the actual bounds? What are the curves? So the curves they're giving me are y equals 2x plus 1, and that's the upper bound, so this should be the higher one, and y equals x squared plus 1. So it appears the worry is that students are really uncomfortable graphing those. And that makes me wonder, if you go on in future courses, the ability to know those graphs is really valuable. So I've been thinking about what could I provide for students, and if you have ideas about that, to give them practice with this. I did at the beginning of the term made a video about how to quickly graph all of these functions, but maybe we need to incorporate that sort of review and more into our work. So there's some sort of disconnect here. But that's what we need to graph, is we need to realize this is a line and this is a parabola. We do not want that to bug us. We really should know a little more. And I'd never mean something like this as a criticism, but I would argue that this is more valuable than anything else we're doing. So if you're struggling with the graphing, it's worth just going to the tutoring center and doing a bunch of these, trying to graph on your own, and then talking to a tutor about where you're getting stuck. Now, when I graph this line, I know the slope is 2 and the intercept is 1. And so in my head, I already have a picture. I also know that I should probably check what happens at 0 and 2, because that's where my tick marks are. So I'm really inclined to plug in 0 and realize that it's 1. So by two different measures, I know that that's 1. I can plug in 0. I also know it's the y-intercept. When I plug in 2, I go up here to 5. So I have this 2, 5. Let me get rid of this picture. This is the volume we're doing. Let me just move it. And this is 0, 1. But as always, the reason I'm making this is to give you a chance to kind of reflect at where the problems are. Okay, so that's the line I definitely would have drawn. In addition, I would draw this parabola. Now I know this is a happy parabola. In my head, I'm thinking this because this is positive. I know that when I plug in 0, I'm actually at the vertex. So that is a lot of stuff. That's what you do in pre-calculus, but we really need it. We need to be able to see these graphs. But even if you were stuck, you would say, well, when I plug in a 0, I get a 1. Maybe somebody didn't know the vertex, but I would argue that we should know that that's the standard parabola and that this is just shifted up 1. But anyways, when you plug in a 0, you get a 1. When you plug in a 2, you get a 5. Oh, that's interesting. So it's this parabola, it hits here. This sliver. So I know that some students are getting that no problem, but there's a sizable percentage that still get stuck on that, and I would argue that that's something that we need to all think about. What can we do to make that a little better? Because that's just going to affect you for so long, knowing your standard graphs. Okay, so anyways, that's really what the question's about, is drawing that picture. Once you draw the picture, it's about relabeling. I'm just going to get rid of this for a second. So how do we relabel? We say, well, instead of it being based off of X, I want it to be based off of Y. And I want to say, for a given Y, what would the tick marks be? what is the biggest and smallest y can be. And we can see that the smallest y can be is right here, and the biggest y can be is right here. So I can see those values right now. But I had to draw a picture to see them. So some students, I think, had an inaccurate picture. That's where they were getting it wrong. But anyways, the inner bound should be the functions. And this should be the smaller x value you get, and this should be the bigger x value you get. So what we mean by that is if you start walking out towards the region, walk, 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 you hit something. That's the smaller x value right here. I find some people just have trouble thinking horizontally. If you keep going, this will be the larger x. But I need to figure out what those x values are based off of y. So I need to take my functions, y equals 2x plus 1, and get my x value based off of y. So I could say x equals, so I'm going to subtract the 1 to divide by 2. Done. That's the smaller bound. That's the point on this line that you get when you plug in y. That's the lower bound. So y minus 1 over 2. You can plug in a few things to check, like when you plug in a 1, you get a 0. Okay, that's good. When you plug in a 5, you get a 2. Oh, that's good. And you could try a few others if you wanted. All right, now the other one, the larger one. So that comes from the parabola, but I need to rearrange. And I get x is plus or minus the square root of y minus 1, but I can see that it's positive x's. The negative x's would be the other side of the parabola. So I'm going to plug that in. And you could plug in numbers that. When you plug in a 1, you get a 0. When you plug in a 5, you get a 2. When you plug in something in between, like a 2 or something, you should see that when y equals 2, this number is bigger than this number. One of them's a half, one of them's just 1. Okay, that was what that problem was. These are really kind of quick problems. It's something we need to be prepared for, but it's not something you can fake. You have to know where you're looking. And this ability to label regions isn't going to go away. I have a lot of practice on this. So before you go into future courses, if you're struggling with that, check out my volumes, and more volumes videos. I think I have one that's just about how to label a graph. Those skills are really valuable. Okay, lastly, we had a volume here. And these can be confusing because it feels like there's so many equations. We have this equation. We have this equation. We have this equation. And we have this equation. And I'm claiming that those bound a region. Now, I have a very clear process that I gave for doing these sorts of problems. But I just thought I would say, you know, when I give a problem like this, it does indeed need to bound a solid. So if I started graphing these, and you didn't have a graph, and you didn't need one, it does indeed bound a solid. Now, this doesn't completely bound, but as soon as I put in the y equals 4, it does. So it's the thing that's inside all of those. Ooh, it's hard to see that. I'd have to strip away some stuff to see it more clearly, and I'll do that now. That's the volume we're computing. So a little weird wedged parabola shaped thing. Okay, so let's compute its volume. Shrink this a little bit. There's a clear tool, and the tool is a double integral. But the double integral requires two things. It requires a region, and it requires a surface. Now, surprisingly, I had a few students that tried to do it in terms of y or z, but I told you that any problem I give you, I would make it so that you could use z as your output variable. So because I had said that, there's no reason to try other output variables. You really should have just immediately put this here. If you did it correctly by having some other variable to be output variable, I'll give you full credit, but I didn't see anybody do it correctly. I saw a few people do it incorrectly. I don't know why they were trying that. So that's step one. We talked about that, how you can immediately fill your integrand in. This will now compute the volume above some region on the ground and below this surface. Okay, so now the next step is, what is the region on the ground? So if I took my 3D picture, I can see it. It's right here. It's like the shadow on the ground. But all you really need to do is graph these. So I talked about how all you have to do is find the z's and then graph the bounds that bound x and y. Now sometimes there's a little more to work and there's a little bit of visualizing, but that was not true in this question. You graph this, you graph this. Y equals 4. Now, some students made an additional assumption. Now, nothing in this problem mentioned the x or y axis. So this is the region. So I find that the axes sometimes cause trouble because the problem did not mention those axes. So a lot of people had half the volume because they didn't deal with the whole thing. We'll be done the moment we can describe this. Now, my perspective would be, I think I would like to do it in terms of x. And so I need to find a pattern. If I walk from a given x and hit the region, that's the smaller bound. That's the bigger bound. So for all x's from -2 to 2, I have the integral from the bottom, which is x squared, to 4. Now, if you did not have a variable in here, and that's going to be a big deduction, it's not a rectangular region. At that point, then it was computing. There is another way to do it, which is you could label it in terms of y. You then have to solve for the x value on both sides. And that would look like the integral from, let me get my picture out of the way here. The integral from 0 to 4, negative square root of y to square root of y of 2y dx dy. So both of those were acceptable setups. Then you were just computing. So it's y squared from x squared to 4. So it's the integral from -2 to 2 of 16 minus x to the 4th, which is 16x minus 1/5 x to the 5th from -2 to 2, which was 32 minus, I think that's 32/5. Note when you plug in a negative, you're going to get the exact same thing, but with opposite signs. So at this point, I probably would just multiply it times 2, but I'll write it here. -32 plus 32/5. So I'm seeing that it's 64 minus 64/5. If it was me, I would factor out the 64. And so it's 64 times 4/5, which I think is 256/5. And you didn't have to do all that simplifying, but it's then simplifies. Now, yeah, 51.2. That's the volume of that shape. All right, hope you found that helpful. All right.